So what I want to do here is talk about how to solve a basic Punnett square problem, and I know most of you will find I know how to do this already, and that's no problem. If you feel really comfortable with it, you can move on. My big concern sometimes is that people don't necessarily understand what they're doing with a Punnett square, like the fundamentals behind it, and that will cause problems later on when the Punnett squares and the problems get a little bit more difficult. So I'm just going to go through this to show you how I would tackle this in a step-by-step fashion. So you see the question there. The very first thing that I'm going to suggest you do is identify the symbols that you're going to use. We've been told that tall is dominant, therefore we'll give it a big T, and short is recessive, so we'll give it a little t. You have to use the same letters, and the dominant one is always capitalized. The second thing you want to do is identify the parental genotypes. Now, depending on the problem, you won't necessarily be given that. Sometimes that's the question, you need to figure it out. But if you are given it, you should identify those. And so this is fairly straightforward. We're talking about two organisms that are heterozygous, and that's the parental genotypes. So from here, what we can do is start our problem. Now I'm going to tackle this a little bit differently. Instead of just using the letters, I'm going to actually start with chromosomes, because that's where I find things go poorly. Let's say we've got two chromosomes in one parent and the same chromosomes in another parent. And there is their genotype from a chromosomal standpoint. Now again, what we're going to do next is we want to identify the gamete genotype. So what are the genotypes of the gametes that are going to be produced from both these individuals? So this one, if you pull it through meiosis, you are going to produce four different gametes. But of course, in this case, there's only going to be two different ones in terms of their genotypes. So I'm just going to draw two of them. Okay, and you will separate those out. And the same thing is going to be happening for this individual over here. Exactly the same. Okay, so those are the gametes and the gamete genotypes. So there are the eggs and there are the sperm. So there you go. Now from here, it's pretty straightforward to make your Punnett square. So we'll do that very quickly, somewhat messily. I apologize for that. Now remember, what we're doing here is we are basically saying that is the chances of, you've got a 50-50 chance of each of those gametes coming along. And this is how you end up with the basic Punnett square. And you can go ahead and fill those in. And that is what you are left with. Now the final thing that's really important, and sometimes this is where people slip up, is they don't actually answer the question. So you got your Punnett square nicely done, but you actually have to answer the question. The question was, what is the genotypic frequencies, not the phenotypic frequencies here. So we've got one of those, one homozygous dominant to two heterozygotes to one homozygous recessive. And yeah, you probably could have figured that out much quicker, but those are the fundamentals behind it.